Hello, physics students. So today we're going to collect data for the Waves on a String lab. In this lab, I had students set up a frequency generator onto an oscillator. The oscillator is creating waves on a spring, waves on a string, and we're going to see some standing waves given very specific frequencies. So I have a weight at the very end of this string here, and that creates a tension on the string. We're going to collect 5 pieces of data for low tension, which is 150 grams, and then we are going to increase the tension and collect 5 pieces of data of that so that we can compare and contrast what our results are for high and low tension. So I'm going to change the frequency on my amplifier until I see a standing wave on my string. So if I can get both on the graph itself, you can see part of the string there, but I want to get a low frequency. And as I get a low frequency, I should be able to see some standing waves being generated. I see some really small ones right now, so I'm not going to stop it until I see it pretty clear. And I'm going to increase the amplitude here as well. So at this point, I can see that I have a really good standing wave. That has a frequency of 111.7 hertz. And at that point, I'm going to actually measure, or you're going to measure what the wavelength for that frequency is. So you're going to jot down that frequency on a data table that you're creating on your sheet. And then when you measure a wavelength, you want to make sure that you start at what we call a node, go up to a crest, back down to a trough, and then back to a node. So a lot of students measure waves from crest to crest, but in this case, this is one wave, and this crest up here is the reflected wave. So they're separate waves. You don't want to measure from here to here, but you want to measure from one node up a crest, down a trough, back to your third node. So you should have 1, 2, 3 nodes here. Measure this as best you can. And of course you can pause it and replay it based on your accuracy of data collection. And since we're not here in person, you might have a little more source of error, and that's fine as long as you get a decent line of best fit. Okay, I'm going to move on to my next frequency. Okay, I feel like I have a really good standing wave here at 104.1 hertz. So let's measure out a wavelength there. I'm going to start at a node and try to get as close as possible so you can measure one node out to the third node. I feel like I might have lost So we're going to try this again. I have a frequency of 106.7. Let's measure out one full wavelength. I start at 0 centimeters, measure it out to one full wavelength as best you can, and record that for 106.7 hertz. This is in centimeters, don't forget to convert it to meters. Moving on to the next frequency. I've got pretty good standing wave here. My frequency is 97.7 hertz. And you can measure your wavelength here. Fourth data point. So this one looks like it's staying pretty still. This has a frequency of 74.3 hertz. And we're going to measure one wavelength here. And then one last frequency. That looks like a good standing wave. This one is at 57.6 hertz, and we want to measure one full wavelength here. All right, so that should be 5 pieces of data for your frequency and wavelength of your low tension. I am going to turn this off and add more mass. And when I add more mass, I'm going to end up, instead of 150 grams, I'm going to end up with 250 grams. So this creates much higher tension than the previous demonstration. So let me get to an appropriate frequency. This looks like a good standing wave right here. I have 93.2 hertz for my frequency, and then you can measure your wavelength here. Convert your centimeters to meters. I'm going to go down in frequency and try to get my next standing wave. That looks like a pretty good one. All right, that one is exactly 70 hertz, and you can measure your wavelength here as best you can estimate it. And then moving down, I've got 58.4 hertz, so let me show that to you. 58.4 hertz. And I'm going to try to squeeze in 2 wavelengths here. Do the best you can to measure this. And after this, we might have to measure our wavelength a little bit differently. And I'll show you how to do that. So that's our third frequency and wavelength data point. We're going to go down. Looks like a good standing wave. Might be fluctuating a little bit. All right, so this frequency is 46.6 hertz. I've got a standing wave here. It's a little bit harder to measure one full wave. So what I'm going to have you do is measure half of a wave. From node to node is half of a wave. Measure that and double it to get one full wavelength. And then the last frequency so this one looks like a good wave. I have 23.3 hertz. And I'm going to have you measure one full wavelength, which, let me see if I can get everything in there. is going to be from this red oscillator out to the first node. So do your best to estimate that, which is half of a node, and then double it to get a full wavelength. All right, you should have enough data collected for the low tension and the high tension, 150 grams and then 250 grams. And then when you plug it into your Google Sheets, which is in the announcement as well, you should be able to take that data to analyze it and answer the rest of the questions in the lab worksheet. All right, physics students, so what we're going to do is I'm going to walk you through how to graph this lab. So where you can find all of this information is obviously in your Canvas page where you have links to absent materials. The video for the data collection you already have, and there's a Google Sheets link right below it where you can take all of the data that you collected and put it into this Google Sheet. So it's a little bit different than the type of graphing we normally do, and the reason why is because we now have to graph two different pieces of data into one, and so I want to show you how to do this. First, we've got two different tensions, and so you're going to plug in your frequency, which is your x-axis, in two different columns. So whatever your wavelength is, let's say it's a wavelength of 1 meter, and you have a frequency of 20, it's going to automatically populate not only in the graph down here, but also automatically populate in the wavelength and period graph. So you don't have to do that calculation by hand, unlike the students in class had to do. Let's just populate some more data, and I'm making all of this up in my head. Notice how as I plug in the wavelength and the frequency for the low tension, it's going to give me a linear graph. This one is not going to give me an equation. The period is going to give me an equation here. Now, let's plug in some data for our other graph. Let's say we got a different wavelength, because you will, and I got a frequency of 25. Notice how that's a red dot now. Let's say I got a frequency of 1 and 35. So now we're going to have a second graph populate for your 250 gram data. So you're going to see both of them separately, but on the same graph so you can compare and contrast. Now, how do you interpret the equation? Well, in Google Sheets, it makes it easy for you because they give you the equation as the slope times your x value, which your x value in this case is going to be your period, and then plus your y-intercept. So they don't give you the y variable. The y variable is your wavelength. That's this column right here. So you've got your slope, you've got your wavelength equals negative 0.25 is your slope times your wavelength. So as you plug in values, and you're going to plug in your own values, this I completely made up and your graphs are not going to look like this, but as you plug in your values, you are going to see a linear representation or relationship between frequency and wavelength, as well as wavelength and period. I didn't actually fill in the x and y columns for you. This is wrong, so I'm going to have to reset that. It is wavelength on the y-axis and frequency on the x-axis. So I'll make sure to fix that when you're ready to do your lab. All right, good luck. Use this information to finish off the rest of your worksheet, and you should be good to go.